All right. Hi, everyone. Thanks for coming. So yeah, we're going to be talking a bit about observability, specifically with things that are the CNCF landscape or open source, and just like things that we have some experience with in some way. And it's also kind of fun since I've been doing a conference circuit since March, and the first talk that we did was an earlier version of this, and now I'm ending it with it. So yeah, hi, I'm Tiffany Jernigan in developer advocacy. I guess if you're hiring, come talk to me, please. My website is currently slightly broken, I was told, so all my talks are jumbled, but I'll fix it later. And if you use Twitter or X, that's my handle over there.
Okay, my name is Matthias. I work for a company called Novatec here in Germany, where I try to help our clients, our internal people, and also outside of the company, students on their way to the cloud-native journey, adopting to technologies, applying modern software architectures with it. And out of this is also where the talk originated. So one of the big issues we have today is that we have only 30 minutes, or like only 28 left. I think they stole 2 minutes from us. Last year, we did this talk in a 3-hour version with a lot of live demos at DevOps Belgium. So today we have to sacrifice the demos because of time, but if you actually want to look into some of the things that we're showing today in a longer and deeper kind of version, then feel free to check that one out. All right, so let's get started. Why are we doing this? We have heard this morning already about Kubernetes complexity and many different primitives and so on. So getting an understanding what is happening in and around the cluster is something I think everybody knows. Everybody from us knows how that is. So why is that actually so much of a problem? The major thing here is that it's a lot of kind of components and pieces that fit together to a larger thing that makes it hard to get an understanding of it. So we have like the infrastructure side with the Kubernetes worker nodes and control plane. We have the API objects that you need to learn and understand and how they relate to each other. And that is, like, last but not least, the application infrastructure running within the cluster itself. So to get an idea and understanding how all of those kind of relate and what to observe and look out for is basically the big challenge. With that, there are also several different options how you can observe and get a feeling for what's going on. So you have different ways how to place your, let's say, agents or data collectors or anything that gives you metrics and information about all the things that I just mentioned. So you can place that, you can reach out to the API server, you can place things on the node, you can place something in the pod. Or in the application itself. And that's kind of the idea of this talk, to kind of categorize the various options that are currently out there, or at least the one we are kind of familiar with, and give you a bit of an understanding on how much you actually have to kind of invest. And I'm not talking about like money-wise, it's more like installation, setup, and overhead-wise, and what would you actually get in return. So basically to get a feeling, this is really what I need, and this is probably what I'm willing to give. There are tools, you probably know that. There are lots of technologies in and around the Kubernetes or CNCF ecosystem. I made this little diagram for another presentation recently that shows the evolution of the CNCF landscape. So in 2017, believe it or not, it looked as tiny as this on the left-hand side. And there were also already some observability solutions in there, like Jaeger, like Open Tracing, the Envoy proxy, Prometheus, some things we're going to mention today. It grew bigger and bigger, and I think this year they started to change it from a landscape into a portrait mode, so you can just scroll more. And that also shows with the increasing amount of technologies, there's also an increasing amount of observability technology. It has its own dedicated section. And yeah, for today, we're going to pick out some of those tools and show you what they can do for you. So I'm going to start this kind of journey by explaining a couple of options in the Kubernetes API. Then Tiffany will go into the pod-based and node-based solution, and I'm going to finish it up on the application side of things. So yeah, getting into the API server and querying metrics there is probably not what everybody would call observability. But still, it has the possibility for you to detect and figure out if things are going wrong on a high-level basis, and then starting from there, getting deeper into it. So this is probably also the part where when people start getting into touch with Kubernetes in the first place, working on the kubectl API, doing things like get, describe, logs, debug, exec, and then figure out how your objects are behaving and if things are actually fine. There are also tools in that space that basically rely on that API. So you get web-based, fat client-based, or CLI-based toolings. And I've been working on doing this talk for quite a while. In the beginning, I was highlighting technologies like WeaveWorks Scope, Octant from VMware, Lens, and K9s. And this is also a bit of the tricky thing here with this open source solution. Some get deprecated or discontinued, some turn commercial. So for this talk, we try to stick to mostly open source stuff. So we have to highlight K9s here. This has been a good friend all the time. There are new ones, or not really new anymore, but there are more established ones and still active ones now. So there's Headlamp and Skooner. There is actually a talk right after this, more in depth on the Headlamp thing. I'm going to point it out in a second. So how those tools work, so we don't demo here now, just a few screenshots. This is K9s. It's the older ones in the room here might still remember a thing called the Norton Commander. I used that when I was young. So this is the Norton Commander for Kubernetes. You can, on a text-based thing, browse around your cluster, look into your objects. You can get high-level metrics, logs, and things like that. So that's a good place to get started. This one is Lens, the one I used to use quite a bit until it turned commercial. There is an open Lens alternative now for those who want to check it out. And this is, as I said, the Headlamp one. So there's a little picture of Andy, our friend. He's going to give the talk right after this one. So if you want to know more about that, just stay here in the room and you're going to be fine. This is Skooner, same thing in white. I also think they have a dark mode, but I just took the white one here. So what they're going to, in the end, all of those tools, they're not going to give you more information that you would get out of the Kubernetes CLI, but it's in a nicer an aggregated form. So you get a bit of a navigation, you can browse around easily, you can actually use a web-based approach and then, for example, open up a shell into a pod, aggregate the logs and the metrics that you see. So it is a helpful aggregation for those high-level metrics. And that's kind of what this is about. The good thing with those, it doesn't require any change to your cluster. So you don't have to modify anything. You don't have any security issues there. They're completely non-intrusive as opposed to other solutions that we'll see later on. And especially for those ones getting started with Kubernetes, I don't think that's the majority here, but still a lot of people are still learning and getting into it. Those tools can be a big help. However, you don't get any network insights, you don't get any deeper level applications insights. You need more things on that later, as we can see later on. So yeah, I'm going to rush a little bit. So Prometheus and Grafana was originally not a part of this slide deck, but I got feedback a couple of times saying you can't talk about observability without mentioning Prometheus and Grafana, which is about right. Well, for now, I just showed a high-level kind of architecture where you can see, okay, Prometheus is that kind of time series database that can get information from different kind of sources, puts it into time series kind of saving mechanisms, and then the Grafana dashboard will have the possibility to visualize that and create custom dashboards to your likes. We will see the combination of both further on in this talk, as a part of other solutions that we're going to show. And with that, I'm going to hand it over to Tiffany for the pod-based approach.
Thank you. And this is a cool little clicker. It's almost like a little phone in a way. But yeah, since I'm short. All right, so yeah, going to be talking about things on a pod-based side, specifically with service mesh. So you may remember this diagram just slightly differently. For this, basically, we're placing the agent in a different place. Before, we were going from the API server, whereas now we are specifically doing it with our pod. So we can see that we have our app running there, and then there's this question mark that we have there, which is going to be our proxy. So this is just a little example for you have your pod, you have your application that's running on your container, you have your network traffic, and so everything all your containers, which is just one in this case, is connected to your network traffic. So this also means that if you end up having multiple applications that are running inside of the same pod, that they're connected to the same network traffic, this isn't so useful to have two different applications. Instead, it makes more sense to have something that would be, for instance, your proxy that can go and collect network data that is your application specifically seeing as well. So it's not so useful if you just have it on like one of your applications. It makes sense to end up having it for every single one of your applications. They can't see what's happening between each other, but you have your control plane that goes and collects all the data from that and aggregates it, and then you can do things like applying policies, different rules to direct traffic, et cetera, just like depending on what you want to do. You can see like how long a trip may end up taking, and just getting more information based on that. So one of the really cool things is that it's independent of like whatever framework you decide to use. You can have your application. You can have a Go application. You could have an application that is in Java. It just really doesn't matter since it is not specifically affecting whatever you're doing with your application. You don't have to change your application to have that there. And with this, though, you can't get app-specific metrics, but you can go and get things with like network metrics. So it just kind of limits the depth of what you can see, but it makes it independent of whatever you're running. So one of the other things about that is that you don't need to go and manually restart or rebuild your application. You can say, OK, I don't actually want to use this anymore for whatever reason, and you can go and pull that out. The one thing is that it will, like, adding a sidecar or changing that or upgrading it will end up restarting your pod, which could potentially be an issue for you. But you don't have to go and change your code at least. So basically, all of this, again, ends up feeding into your control plane. So now that you have like all that information, maybe you prefer looking at numbers, for instance, but a really good way to go and visualize that is using a tool kind of like this one, which is Kiali. So you can go and specifically see, like, hey, here are the different applications that I have running. You can see that there's, like, for instance, 2 different versions. You can see, like, percentages, like the routing percentages between the different parts, and just a bunch of different information like that, which helps you see more of what is happening. This is a pretty like small application, and so there's not a lot, or like this is for a to-do application. So there's only a few things here. But the more that you end up adding, then it gets even more complicated, and then having something like this is even more useful. Like you can even see like something is wrong with however the wavefront proxy is set up because everything is red. So just getting a much more information there. So obviously, there is a price that you have to pay by putting this in. Like, yes, like it extends Kubernetes, so you can end up being able to see more with things with traffic. But then you also have things like the network traffic being interrupted. So like you have it between app A to app B, from proxy A to app A, so that can go and add a delay. Again, it's just the concept of having a sidecar that is being injected into every single one of your pods that is running alongside of your main application in there. You can't get application level metrics, and then there's things like configuration changes at runtime. So there's a few other limitations that there are for having sidecars. There's some blogs that are out there that Istio has posted also quite recently. So like, for instance, again, basically, if you do an installation or adding a sidecar, or if you go and upgrade a sidecar to another version, that ends up resulting in your pod going and restarting, which could end up interrupting your workload. It might mean somebody can't actually access something. There's a large resource consumption, so like CPU and memory, like they must be provisioned for like a worst case usage. And then say you have 1,000 pods. So within there you have 1,000 containers, but then now you have another 1,000 for every single one of those proxies. And then sometimes applications could also be broken when the sidecars are added. So that brings us to the concept of having node-based versus having something that is with a sidecar. So again, with our diagram here, but the difference is we are looking specifically at our nodes. So our agents are on the nodes instead of within each of the pods that we have. So that's the whole idea of like some of the downsides of having a sidecar-based approach is where Istio decided to start working on this thing called Istio Ambient Mesh. On the right side there's a talk that Abdul over here did 2 weeks ago now at DevOps Poland. And then Lynn is doing a talk on it more tomorrow as well, so you should go check those out. Basically, instead of having it be a sidecar, you end up pods that are running specifically on the nodes that you don't have to go and worry about, oh, hey, I need this sidecar to be up in order to get network traffic information for my pod. And it's not specifically tied to every single one. You don't have to have like a sidecar for every single one of them that's specifically running in there. You don't have to have it on both sides that's communicating with that. There's just a bunch of different things that ends up trying to fix with those limitations that I had just gone over. And again, there's a blog that just came out actually last month, since it's now in beta as of version 1.22. So another way of going about things is with this thing called eBPF. So I'm going to go into that a little bit. It has a very long name if you want to go with the whole thing there. But so basically, it's a pretty low-level functionality. So like, you have this concept of like your kernel space, which is where your kernel software ends up running. This usually is a pretty protected environment for like safety reasons. It's also pretty difficult to change. So for instance, if you try changing something and you're like, hey, I need this to be in like the next version of Linux, maybe that'll be a few years from now or something, which is not going to work out. So like, the things that are normally changing generally are in the user space. You can kind of view it as like comparable to like JavaScript in the web page. Basically, that eBPF sandbox is kind of that in the kernel, so you can run custom code, but you don't have to worry about like harming the actual environment that's there. And then like in the kernel space, it can interact with like kernel events, such as network events, and then you set things over like with the SDK and libraries and tools over on the user space. So typically, not always, but typically with containers, the underlying operating system usually is Linux. So basically, this makes it a lot easier for being able to just like use this technology and be able to inject code to create the metrics based on that. So like this diagram is specifically for eBPF, but it's also kind of, you can look at it for other things as well that are node-based. But like here we have the eBPF edge. You can see that it's running on every single one of these nodes, and then we have the eBPF control where everything on the control plane where everything is being aggregated. So again, you have hopefully way fewer nodes than you have of pods running, so there should be fewer there. And so, like with using like what we were looking at before, there's a tool for Cilium. This is Hubble. And you can actually go and see, this is the same application running, the Spring Pet Clinic, if you've ever seen that one. And you can get things like traffic flow. You can see like who is talking to who and what the traffic flow is. What you don't get directly from this dashboard are like metrics like with response times and throughput. Cilium does have these things, though, just not specifically in this dashboard. So instead, this is where another place where Prometheus and Grafana come in, and then you can basically get that type of data. You can see like the response time for overall requests. You can see the trace view that's down there below as well. So this can just help you visualize more of the different data that you have there. OK. So this eBPF thing is not like super new anymore, but it just like kind of gained a lot of popularity, let's say, in the last 2 years or so. Cilium is probably the #1 technology that stands out here, but in the context of that, quite a few other technologies have emerged. I mean, Pixie is, I think, the technology when I encountered eBPF in the first time, and there are more things growing out in that ecosystem. I think they even have an own landscape now. So if you go to the eBPF ordered applications, you can like search for new cool tools that might help you in your observability quest. For example, here you can see CubeShark that also draws a topology map and shows the correlation between all the components that are in your environment. And all of these metrics and information is just being grabbed by eBPF without the need to inject any kind of custom code into your applications itself.
Another thing that gained much more popularity is the topic of profiling. So the graphs that you see on the things like this flame graph kind of style, they also became a lot easier with eBPF to run things on the kernel and find out, taking snapshots at a certain point in time and say what is currently being executed on the CPU and what is the behavior of my application. I mean, with that, it's not possible to correlate the individual method calls as in a tracing style, as we see later. But still, you get deeper and deeper into the part, like how does Kubernetes, the hardware, play together with my application and so on, and can you identify things that are kind of out of the norm and need some more special attention. Yeah, I'm going to say a few words about profiling later on too, but to close this thing up that Tiffany started, so on that node-based thing, you basically inject your proxy or agent or data collection component on the node of the Kubernetes cluster. And then as it runs on that Linux kernel, it will be able to grab all the necessary information from there, and you don't need to rely on and manage a service mesh which is kind of basically sidecar-based. It has lower latency because there are not as many hops in there. You should most likely have less nodes than you have pods in your environment. And you leverage low-level Linux functionality for those Kubernetes purposes. And as I said, this technology and this approach seems to emerging fast. We also see that with the now in beta mode ambient mesh on the Istio side. So I'm definitely think there is more to come in that area. Now I'm gonna finish things here and by looking into application-based monitoring. So that means we have seen various levels now, went from the API server to the pods, to the nodes, and now we basically want to get into the internals of the application. That also means we have to place the agent as close as possible to our application. In the end, I mean, many approaches work like that. You collect the data from the application and then install it in a database as well and visualize it somehow. So this approach is not very new. What is kind of new is probably more the nature of applications. So we have, through Kubernetes and containers or container-based microservices, we very often have polyglot applications where it is not so easy to correlate the trace information and make them all stitched together very well. The other problem we have in that space that there are many different toolings and standards out in this world. So it's kind of hard to decide which is probably the right one for your current application stack. So one technology that certainly stands out here, and is probably, I think, the #2 project in the CNCF landscape after Kubernetes when it comes to people participating and committing to the code, is OpenTelemetry. So I'll briefly go into that. Explaining OpenTelemetry in 5 minutes is not so easy. Here on the bottom, we have a sample distributed application consisting of different components. So you have different languages. In this case, it's like Python and Java with different frameworks. And we want to monitor that on a deeper level. So what you need to do is basically put an agent in as close as you can to these application components. There are two ways of instrumentation. So zero code, which used to be called automatic instrumentation, basically you can do without changing anything in the code. It's only the configuration aspect. The manual instrumentation, which we also see, will basically, you have to go into the code to get a more detailed, more detailed information from your application. They will all send the stuff to the OpenTelemetry collector, and the collector will then be able to export 3 different so-called signals. We have metrics, traces, and logs to different backends. So OpenTelemetry is not like an all-in-one solution for observability. It's more like a way of standardizing those signals that we have been monitoring in the past before already. It's like in school again. Almost time for a break. And now, so for example, you could export this OpenTelemetry information, like the metrics towards Prometheus, the traces towards Jaeger, the logs to OpenSearch, and there are different combinations, of course, possible. And this is also one of the good things. It doesn't narrow you down. You can basically decide which kind of agent implementation do you take and what is the technology you export it to. And as I have just mentioned profiles, this was an addition that came to OpenTelemetry, I think this year, or that was officially announced, that with the new gaining popularity of profiling information, OpenTelemetry now also supports profile as an own signal next to metrics, traces, and logs. So that means you can now also correlate your profiling data with like traces, metrics, and logs. So if you have a certain snapshot in time and say, okay, this is what I see there, what have been the traces or the logs at that point, in the end, all paying into that thing that I talked about before, making sure you have the control and the grip over your distributed application. All right, so how does this work? How I'm going to get this kind of agent now into my container? In some cases, it's possible to do that without even touching the application. So this shows a Docker file. It's a Java application. It shows a Docker file where you basically just download this agent.jar file, and then you attach it to your Java process. So this is basically the least intrusive way where you don't have to rebuild your jar, but in any case, you have to rebuild your container. So this is something you must do. And then once it's in there, you need to configure it. Basically, this is pretty simple because what you need to do, you need to tell the agent where is my OpenTelemetry collector, what is my name, so that they can like process my information under a given name, and then they can continue working on that. And there are many different ways to do that. There are also ways how you can like directly hook into the code if you want it more granular. But this automatic kind of component is a pretty like good way to start with. And once you have that, you will get application level metrics. So this is again from a Java application. Now you suddenly know about the garbage collection information, heap size, threads, and so on. These are things that you would not be able to get by the approaches that we have shown before, because it needs to be plugged into the JVM. Otherwise, you wouldn't be able to see that. Now, finally, Jaeger, I've already mentioned as a part. It's not a part of OpenTelemetry, but I would say it regained a lot of attraction through OpenTelemetry. It was there before. So this is a snapshot of Jaeger that gets only data from a service mesh. So I have to take two microservices, one invoking the other. So you basically only see the spans, which just like show what is the time frame for the calls going into and leaving the component. So you can't figure out what is inside. But you can also use a service mesh to feed into Jaeger. This is what it would look like if you have like the OpenTelemetry agent. Now you have that tracing method breakdown on who is invoking whom, and where do you spend your time, and what is happening within the application. So it's really easy to isolate slow-performing methods if you have that kind of information there. Now, if that is not enough, then you can still go into the code. So this sample requires a bit of a Java understanding. So in this case, I would basically have a REST server that takes some items and writes it into a database. And in the middle, I added this kind of some useless method that just basically puts another method in there which processes the same thing. Normally, I would not be able to see that method. So my trace would look like this. The REST call would be invoked, and the things would be added into my list. Now, if I add this with span and also this span attribute, which we will see in a second, this method will now also show up in my trace. So, of course, an automatic instrumentation will not instrument every method in your code. That would be a heavy overload. So they normally just like use the, let's say, edge methods in a framework. With that, you can go deeper and say, okay, this is the additional method I want to monitor. And with that span attribute, I'm also able to listen on the variables that are being passed to that method. So I can basically, if I have a problem that doesn't occur all the time, then I can basically correlate it to what the variables were that were processed at that point. So the time is up. I don't want to take much time away from your coffee break. So the characteristics of that one, yeah, the agents are specific to programming languages, but it's an open standard, so everybody can contribute. With that one, you get all the application level metrics you can imagine. This is part of the process in the container and most suitable for your root cause analysis. So summing all that up, it's kind of tricky. I mean, we don't say one is better than the other, and this is right and this is wrong. So the intention of our talk here really was to give you a bit of an overview what is currently out there. Also, if you have the feeling that there is something special that we forget and not mention or should put more attention to, please let us know. Because we try to update and keep that talk current and at state of the art as good as we can. And I think with that, we should this is the slide deck to that talk. We have made some modifications today, which are not there yet, but I'm going to upload them in a second. And again, the link to our recording if you want to see any of those things in a live demoed way. And with that, we would like to say thank you very much for listening. I'm not sure.
And since this is our last talk during this circuit, do you guys mind if we take a selfie with you?
Okay. Again. Thanks very much. And yeah, I don't know if we have time for questions now. Anyway, we're going to be around. If there's a quick question, is that good? Yeah, if there's a question just at this point, feel free to ask the guy with the mic. Otherwise, just grab us at the coffee booth or anywhere around in the conference.
And there's also an OpenTelemetry related collector talk tomorrow, too.
All right. Thank you.